In this video, we'll identify areas in the brain that are most commonly associated with drugs and addiction, and also explain the factors that contribute to addiction. So drugs work by mimicking our own neurochemistry. So in order to understand how they mimic our neurochemistry, we're going to go over some basic terms. So the first is an antagonist. So an antagonist is a drug that blocks a neurotransmitter. So it goes and it binds that receptor, perhaps, and keeps that neurotransmitter from being able to activate that neurotransmitter receptor. So drugs work by mimicking our own neurochemistry. And before we go on, it's important to have some key terms that will help us understand how these drugs can affect our neurochemistry. The first is an antagonist. So an antagonist is a drug that blocks a neurotransmitter. So it decreases that neurotransmitter's effect. And one way this happens is by that drug actually binding that neurotransmitter receptor, most likely because it resembles the neurotransmitter chemically. And so when that drug binds that neurotransmitter receptor, the neurotransmitter can't bind and then thus cannot have an effect. A drug can also be an agonist. So an agonist is a drug that increases a neurotransmitter's effect. So a lot of the times the way this happens is, again, that drug goes and binds that receptor that's in that postsynaptic membrane, and it alters the way that that receptor works. It's not binding in the same site typically that the receptor would bind. It's binding an alternative site, and it maybe opens that ion channel for a longer period of time or a shorter period of time, or it allows more ions to flow in. It's a variety of different ways where that drug can increase the neurotransmitter's effect. We'll also talk about a few drugs that increase the release of the neurotransmitter. That would also be an agonistic effect. And affinity. So affinity is how tightly the drug binds the receptor. And the tighter the drug binds to the receptor, the bigger the effect is going to be. And those are just a few key terms. There are many others, but in an intro to psychobiology class, we don't have the time to go into that. So you're going to watch a video on this rewarding brain stimulation, and it basically goes over some of Olds and Milner's research back in the 50s, where they accidentally found the reward center when they placed an electrode in a rat. They were going for one area and ended up in another. Basically, then they placed these rats in these Skinner boxes and allowed self-stimulation. And what they noticed is that these rats would press the lever sometimes 2,000 times to stimulate the release of this dopamine in the nucleus accumbens. So they were stimulating the septum that was causing dopamine release in the nucleus accumbens. And that addictive substances also seem to affect these dopamine and norepinephrine synapses. So the question is, what area of the brain is involved in the reward systems? And if you've already watched the Olds and Milner video, you'll have seen that it's the nucleus accumbens. And here's the nucleus accumbens. And you can see the nucleus accumbens has these widespread connections to cortical areas. And this dopamine release and the nucleus accumbens is central to reinforcing experiences. It activates dopamine. So the main brain area that we associate with rewards, which ultimately is associated with addiction, is the nucleus accumbens, and the main neurotransmitter associated with the reward system and also drugs and addiction is also dopamine. So some of the different things besides drugs that are activated are sexual excitement, gambling, video games, things that have the potential for being addictive, but also are pleasurable experiences. So the next question is, what is addiction? So there's many ways to define addiction, but we're going to define it here as a psychological or physiological dependence on something, such as a substance. So the psychological dependence gives us cravings, so that we feel like we really need the drug, we crave the drug. Maybe it's a cue in the environment, or hearing someone talk about that drug, but that psychological dependence makes us crave the drug. Physiological dependence is something that happens upon withdrawal. So when you don't have the drug, your body needs that drug to feel normal. So once you start taking a drug, that dopamine release in the nucleus accumbens, your brain craves that, needs that. And so you have a physiological dependence on that, so that when you don't take the drug, you have withdrawal symptoms. you also may not have the same pleasurable experiences because your body's adjusted to having that drug. So now we're going to briefly talk about some of the factors that contribute to addiction. The first one being tolerance. So tolerance is when someone takes a drug, over time, they need more and more of that drug to feel the same effect. So another way of thinking about it is it's a progressively decreased response to a drug. So as you take a drug, maybe you do 1 line of cocaine, after a period of time, that 1 line of cocaine is not going to have the same effect anymore. You're going to have a decreased responsiveness to that. And you have a loss of enjoyable effects. This can also occur when people are doing other pleasurable activities while they're taking drugs. So let's say you're doing a line of cocaine and you're having sex. Well, the next time you have sex without the cocaine, it's not going to be as pleasurable. You're not going to enjoy it as much. So what happens is, as a result, a larger dose of the drug is needed to achieve the same effect. So in order to have that same experience you initially had, you have to have a larger dose. And that's what this figure is showing you. So here it says little effect, big effect of the drug. Here we have a small dose, we have a large dose. So this is your first response to exposure. And then after repeated exposure, you need to have a larger dose to have the same effect. Another factor contributing to addiction are the cravings in response to cues. So the idea here is that people may learn to associate cues in the environment with the drug. And this is why there's such a huge percentage of people that relapse after they've gone through some sort of rehabilitation and stopped using drugs, is because these cues in the environment can trigger that craving again. So one of my friends, her brother died about 5 years ago of a drug overdose. I believe it was heroin. And he had been clean and sober for about 3 years and was living, when he was using, he was living in South Lake Tahoe, and he had moved away with his girlfriend. They were getting engaged, about to get married. And he decided that, he was in a good place. He could go back to Tahoe and hang out with his friends. And he went back, and something triggered him after 3 years, whether it was, being with his friends, being in the same environment, to use drugs again. And unfortunately, because his friends had continued using and he hadn't, they were using the dose that he had used previously. So when he, our assumption is that when he used that same dose, it was too much for his body and he overdosed. But, it's just that idea that, 3 years doing fine, and then, that some sort of environmental cue can cause that relapse. And that's how strong those cravings can be. There's also brain reorganization that occurs. So we have changes in neurochemistry, changes in brain activity, because these drugs are going into our brains and affecting our neurochemistry. So especially in that nucleus accumbens, and also in the prefrontal cortex. And so this diagram is just kind of showing you changes in activity. Here would be people who are not using drugs and people who are using some sort of drug. So here's a non-smoker's brain compared to a smoker's brain. Here's someone who's not an alcoholic compared to someone who is an alcoholic. And you see decreased activity here, which would be, I believe, the nucleus accumbens. Someone who does not have an eating disorder, and someone who is obese. Someone who does not use cocaine, and someone who's using cocaine. And so you can see decreases activity here, decreases activity here, and decreases activity here. So there are changes in the brain that are occurring in response to this drug use. So these are 3 factors that can contribute to addiction: tolerance, cravings, and brain reorganization.